Okay, good. All right, what we are doing, we're done with two-dimensional. So we're going to work with three-dimensional solids. And so we're going to try to get a hold of what's going on with those. All right, and so we do need to define words on 358. And those words are polyhedron, faces, edges, and vertex. Do what?
You said 558.
I meant 558. No, we're not on 358. Thank you. Vertex. Okay, so these words I need to define real quick, and then we're going to do kind of a table and kind of discover what the main polyhedron we're going to work with is. Let's see if I can get that done correctly. This is going to help us hopefully kind of know what we're dealing with. Let's get this straight. It's not actually straight. All right, there's a lot of dead air, but that's okay. Hopefully you're getting the definition of a polyhedron as a solid bounded by polygons called faces. An edge is where the two polyhedron, the edge of a polyhedron is where the two faces intersect at a line, and a vertex is where three or more edges meet at a point. Okay, it should be easy to tell what a polyhedron looks like a little bit if you have one. Okay, of course, this doesn't really look like a polyhedron, it looks just like a regular triangle, right? So it's important to understand that our polyhedron are just three-dimensional shapes made out of two-dimensional shapes. So this definitely looks like a triangle. But if I turn it like this, it's no longer a triangle. What is it? It's a rectangle. So each face is going to be a little bit different. So we're going to try to understand our first shape that we're going to mainly work with. And it is going to be a prism. And so we're going to deal with a triangular prism first, because I have one. And I'll attempt to spell it correctly. You'll see that doesn't always work. So this is a triangle prism. A prism basically is defined where it has two bases, and then these bases are connected by rectangles. So this is a triangular prism because the base is a triangle, and they're connected by rectangles. That is what a prism is. And so this is what I'm going to do. Here's my base. It is a triangle. Let's look at how many faces we got. That's one. That's two. Okay, and so how many connect the two bases? Well, there's one, there's two, and then there's three. So I counted a total of 5. Is that what we counted?
Yeah.
Okay, this triangle and this triangle, and then one connector, two connectors, three connectors. And the connectors are always rectangles. Edges. Well, edges are easy. 1, 2, 3 edges. Now I'm going to turn it upside down. 4, 5, 6 edges. And then how many edges are connecting it? 1, 2, 3. So that's a total of 9 edges. Vertexes. Those are the pointy parts, right? Okay, the edges were the lines, the sharp parts, the lines. If I do that over and over again, I'm going to get a splinter. So the points right here are the vertexes. So I got 1, 2, 3. Flip it over. 4, 5, 6. All right, that's our triangular prism. Here is a rectangular prism. Technically, that is a square. But is a square a rectangle? It is, so you can call it a square prism, but I want to do this for all rectangular prisms, not just square ones. I just don't have a rectangular prism. I think I have, that one is. That's more of a rectangular prism. Yeah, that one. We'll use that one. That's more of a rectangle. It's important. Prism. And we can look at this one. Okay, and this one's hard to see which is the bases because all the shapes are rectangles, right? So I'll just call this a base. I got a base here, I got a base here, and then how many sides do I have? Well, I got 1, 2, 3, couldn't see that, 3 and 4. So I got top and bottom, so it looks like I got 6 for my rectangular prism. Okay. And I got this specialized rectangular prism. We call this, instead of, we don't usually call it a prism. What do we usually call this thing? We call it a cube, although the fancy name for it is a hexahedron. What does hex stand for? 6, because it has 6 sides. And you know, a lot of people play those games where you roll it and then it has numbers on it. And how many numbers does it have? 6, okay? So it's also called a hexahedron. And we'll look at all that. All right, so then we got to go to edges. Let's look at the edges. I'll go back to this for edges. So we got 1, 2, 3, 4. That's easy. Flip it over. 5, 6, 7, 8. And what connects it? 1, I'm sorry, I meant 8. So 9, 10, 11, and 12. 12 edges. And it kind of makes sense because at each corner you're going to have an edge, right? Speaking of corners, vertexes, 1, 2, 3, 4, 5, 6, 7, 8. All right, we're just going to do one more shape and then we're going to try to come up with a rule. Let's see what I have here. I wish I had the shape that I want. I don't. So we're going to have to pretend that we have that shape. So I want a pentagon, a pentagonal prism. All right, and let's see how many sides a pentagon would have. Well, I know a pentagon is going to have, okay, so that's going to be one face. This is going to be the other face. So it has at least 2, and then it has connectors. So I connect those 2, that's going to be one face, 2 faces, 3 faces, 4 faces, and 5 faces. Okay? So 5 faces going around, 6 and 7. Do we see a pattern emerge so far? All right, edges. I drew this picture out. So edges are easy, 1, 2, 3, 4, 5. On bottom, 1, 2, 3, 4, 5, so that's 10. And then 11, 12, 13, 14, 15. Okay, vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. All right, we got patterns for everything. I'm going to do the easy pattern. So this is going to be for an n-gonal prism. I think the bases, well, the base is going to be an n-gon. Yeah, I need to, don't I? I think the base, ooh, that's too shaky. Stop it. I think that the face is going to be, well, whatever the, how many sides on the n-gon plus 2. 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. I want you to come up with edges, and I want you to come up with vertex. See if you can come up with how to get there. All right, who got this one? It's probably multiplication, isn't it? What number I put here? 3. Say it with confidence, because you're right. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So there are 3 times the edges as there are sides. How about vertex? It's going to be something times n what? 2. 2 times 3 is 6. 2, 4. Okay. So that's how you know how many you have. Okay. And this is important because when you're breaking it down, for example, if we were doing an octagon. If we were doing an octagon, we know an octagon has 8 sides, right? But an octagonal prism is going to have 10 faces. 2 of the faces are going to be octagons. What are the other 8 faces going to be? Rectangles, right? So if we were going to build an octagonal prism, we would need 2 octagons and 8 rectangles. Okay? And so basically, in that MMA, isn't that fought in the octagon? So that's basically they're fighting an octagonal prism without a top, right? Or am I making that up? Is that a lie? I don't know. Some people watch that stuff. I don't really watch that stuff, but I find it interesting that it's an octagon instead of a square. Boxing is a square, right? Even though they call it a ring. Never mind. We'll move on. All right, and we're going to move on to the other main three-dimensional shape that we'll deal with. Okay, the other main one we're going to deal with is the pyramid. And so we're going to do the same kind of thing. We're going to start with a triangular pyramid, and we're going to kind of do the exact same thing so we can kind of figure out how they're built. And that's what we're trying to work with. So triangle pyramid, we're going to need base, face, edge, vertex. And I'll make sure this is kind of in your line of view. Okay, triangular prism. I only have one pyramid. And so what a pyramid is it is going to have a base, and the base could be any shape. In this case, it's a triangle. And then all of the faces are going to be triangles, and it's going to connect to a point. A nice little pretty sharp vertex. Okay? So pyramids are very popular. There's pyramids in, the famous ones in Egypt, right? There's also pyramids in Central America, North America, right? Like the Aztecs made pyramids. Pyramids are very, very popular. Also, pyramids are very popular towards making of, sharp weapons. Like basically the pyramid design is kind of an arrow design, an arrowhead design. Most of the time nowadays, they don't have the sides. They cut it out, and so they just have the edges. But that's kind of what we're looking at. So the base is a triangle in this case, hence the word triangle pyramid. How many faces does it have? Well, I got the bottom, and then I got 1, 2, 3. So that's 4. Edges. 1, 2, 3, 4, 5, 6. Vertex. 1, 2, 3, 4. And my vertex is broken. Someone broke it. It used to be sharp. All right. That's triangle. Let's do the rectangular prism. What am I doing here? Not prism. That's what you guys were making noise for. Pyramid, right? So rectangle is going to be our base. Let's look at our face on it, and I don't have something, so I'm just going to draw it. So even though this is a rectangle, typically you draw it like this to make it look better. Okay, and so okay, and there we go. That's the one you can't see. So let's look at the faces here. We got one face on the bottom. That's your base. And you got this face, 1, 2, 3, and 4. So it looks like you have 5 faces. Okay. Edges. Edges are easy to see on this, which is nice. So 1, 2, 3, 4 for the square. 5, 6, 7, 8 for the rest of it. Vertexes. 1, 2, 3, 4, 5. Okay, did we see where I was pointing to? All right, we're going to do one more, a pentagonal pyramid. All right, let's look at that one. Let's see if I can draw that one. This one's a little harder. Especially to do with the proper perspective, which I'm probably not going to do. All right. Exactly. Okay, not as pretty, but we still can count the sides, the faces. So basically I have one base, and then each side of it is going to have a triangle coming from it. So that's 1, 2, 3, 4, 5, 6. 6. I see a pattern. 4, 5, 6. Edges. Edges are easy to count on the picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10? Is there a pattern? And points. 1, 2, 3, 4, 5. And the one on top. 6. All right. Do the end stuff for all this. For the end-gon. So we can kind of understand the pattern on what we need to build or construct a three-dimensional shape. Okay, what's edge? And what's vertex? Just plus 1? And that makes sense. Going back to here is you got how many ever points your shape has. So in this case 3. If it was an octagon, it'd be 8. And no matter what happens at the very top of it, all of the sides are going to be triangles and they're going to end in 1 point. So it's always going to be whatever's on the bottom, 1 point. This one I like better than this one because in my mind, base means like the bottom, right? That's kind of what you say in English. Just in math, it doesn't mean bottom. It just means whatever's unique about this pyramid. And so in this case, we have two bases. We have the top base and the bottom base. Or we can turn it sideways and we have the right base and the left base. So just know that that's what that is. All right, the last thing we need to do in notes is, I forget the word. It's cross section. The cross section. All right, basically a cross section is if you cut a shape, what would the cross section look like? So let's look at this shape. What if I were to cut the shape right here? Okay, so I'd just cut it like this. It would look like a square, right? What if I would cut it like this? It would look like a rectangle, yeah? What if I cut it diagonally? Might look like a triangle, right? If I cut off the corner, depending on how you do it. So that's what we kind of look at. And I didn't cover this. This guy right here and this guy right here, you can't see them. Those guys, are those polyhedron? No? How about this guy? You can't see it. How about this guy? I drew circles on that. It's a cone, right? But it's not a polyhedron. Why is it not a polyhedron? Because this is not a polygon. This is a circle. So basically what this circle is, you have a circle, but if you have it just like this, what shape is this now? If I would cut this like this, would that just be a rectangle? So basically a cylinder is nothing more than a circle with a rectangle on the side. So I don't know if I can do this on camera, but basically, look at this piece of paper. It's a rectangle, right? Now it's a cylinder, right? Okay, so just know that. And so we're going to teach about the cylinders and stuff. We are just not going to call them polyhedron because they're not. So yeah, that's all we need to do on that. And I'm going to stop this.